The table below shows the rates of births, marriages and deaths in Ireland from 1990 to 2010. The rates are per 10,000 of the estimated population. So for example, in the year 1990 we had 151 births per 10,000 of the estimated population, 51 marriages per 10,000 of the estimated population, and 90 deaths per 10,000 of the estimated population. And we have that situation, we have all these values up to the year 2010. Here we have a stem and leaf plot of the marriage and death rates. Okay, we can refer to the number of marriages per 10,000 of the estimated population as the marriage rate. Similarly for the death rate, that's the number of deaths per 10,000 of the estimated population. Okay, so we start with the smallest value for the marriage rate. So we just go up to the table and let's look at the smallest value. The smallest value is actually 43. Okay, so that's the first value that appears here. So the stem here is 4. That's the first number in the stem. And the first leaf is 43. 43 actually occurs twice. 45 occurs twice, 46 occurs twice, so does 47, 48 and 49. So these are all the 40s, values between 40 and 50. And the next stem is 5. Okay, so we are interested in values between 50 and 60. So if we go through the table, which I won't really do, but you'll see that there are 3 50s. Okay, so if the stem is 5, we represent those values with leaves of 0 each. So we have 3 leaves with value 0. And there are 3 51s if you check through it, 5 52s. The next stem is 6. And if we go through the marriage rate, number of marriages per 10,000 of the estimated population, we see that there are no values of 60 or more. Okay, so all these values here for the first 2 rows give us the marriage rate. Now we want to also show a stem and leaf diagram for the death rate. We show those values here on the right hand side. So if we go to the death rate values, we will actually find that the lowest value is 61. Okay, so that's the first value here appearing here in the table, and 63 appears twice, 64 once, 67 once, 68 once, and next value is 71, and so on. We keep going to the largest value, which is 90. Okay, there are 3 values, values that are 90. Okay, I can just locate them here. That's 1, 2, 3. State one difference that can be observed between the distributions of the marriage rate and the death rate. Well, you can see that, you know, the distributions of marriage and death rates are very different. One difference is that the marriage rates are grouped at the top of the plot, whereas the death rates are grouped at the bottom of the plot. Next we will get the median and interquartile range of the yearly marriage rates. So to get the median, we will start by getting the total number of values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values here, and we have another 11 values here, so that's 21 values in total. Now 21 is an odd number, so the middle value is, well, the median is the 11th value. Okay, so the median is actually one of these values. It's the 11th value, because there are 10 values below this, whatever the 11th value is, and there are 10 values above it. Okay, the same number of values below it as above it. So the data are automatically in ascending order from the smallest, which is 43, to the largest, which is 52. Okay, we want the interquartile range. So to do that, we get the first quartile. Now the first quartile is the median of the bottom half of the data. So the bottom half of the data are all the values that are below the median, all the values less than 50. So it's all these values from 43 up to 49. Now we see that there are 10 values here to consider, and we want the middle value. Okay, now 10 is an even number. Okay, so we have 10 values. So the middle value would be between the 5th and 6th values. Okay, so we'd have to get the mean of the 5th and 6th values. So this is the first, next we have the 2nd, 3rd, 4th, 5th. So the 5th value is 6, the 6th value is 6. So we would have to get the mean of these two values to get the median of the bottom half of the data. Okay, so the 5th value is 6, the 6th value is 6. We add these together and divide by 2, and of course that will just give us 6, straightforward in this case. So that's what you do when you have an even number of values. To get the median, you find the two middle values and get the mean of those two middle values. If we had an odd number of values here, then the median would be one of the data values. It would be included, it would be the middle value. We wouldn't have to do any calculating. Okay, anyway, the calculation here is, well, we don't even have to calculate this because these two values are the same. So the median of the lower half of the data, and hence the first quartile for the marriage rates, is 46. Okay, so that's the first quartile. Now the second quartile is actually the median. The third quartile is what we need to get next. So we need the first and third quartiles to get the interquartile range. Okay, so that involves looking at the top half of the data. So the median is 50, so the top half of the data is everything above 50. So it's all these values here. So if we count these values, we will see that there are 10 of them. And we want the middle value. Okay, so 1, 2, 3, 4, 5. So we go to the 5th value and the 6th value in these 10 values. Okay, so you know, we've an even number just like before, so we have to look at the 5th and 6th values, add them together and divide by 2. What are we adding together here? Well, we're adding together 51 plus 52 and dividing by 2. And that's going to give us 51.5. Okay, the interquartile range is just the difference between these two values. It's a measure of spread or dispersion of the marriage rate values. Okay, the distance between the lower quartile and the upper quartile, or the first quartile and the third quartile. Okay, first quartile sometimes called the lower quartile, third quartile can be called the upper quartile. Okay, it makes sense because we're dividing the data into 4 parts, if you like, 4 quarters. Anyway, that's a measure of spread, how spread out the values are. So it's 51.5 minus 46. So I'll abbreviate interquartile range by IQR. It's 5.6. Now here we have the mean debt rate in Ireland from 1990 to 2010. So to calculate that, we need to sum all the debt rates and divide by the number of debt rates. So if we go back to the table, or just to our stem and leaf plot, you know, we just need to sum all these values and divide by the number of values. So we're just summing this column. It's the debt rate column, the number of debts per 10,000 of the estimated population for each year. So we're getting the mean of all these values. So this Greek letter is an uppercase sigma. So that means we're summing all the values. Well, the letter X here stands for the values in the death rate column. So we're summing all those values, and we're dividing by n, where little n stands for the number of values, the sample size, which is 21. So the mean death rate is 78.3. The standard deviation of the death rates in this table is 10.3, and we want to list all of the death rates that are within one standard deviation of the mean. So the mean is 78.3, so we want to list all the death rates that are values that are 10.3 but units below 78.3 or within 10.3 units above 78.3. So that's the range this is the range that we are interested in. We're interested in all the death rates between 68 and 88.6. Okay, so those death rates will be within one standard deviation. That is 10.3 of the mean, which is 78.3. So here is a list of those values. In 2010, the number of children born in Ireland was 75,174. Use this number to estimate the total population of Ireland in 2010. So let's look at the birth rate for 2010. So here it is, 165 children born per 10,000 of the population, of the estimated population. Okay, and the total number of children born was this number, so we want to divide this number by 165. Okay, to see how many times this fits in, so each of these values corresponds to 10,000 people of the population. So if we divide 75,174 by 165, we will get the number of these values. So we need to multiply that by 10,000 to get an estimate of the population. So we get 4,556,000. Next we will estimate the number of people who died in Ireland in 2010. So let's go to the death rate for 2010 at 61 people for every 10,000 of the population. So we want to see how many times 10,000 fits into or divides into the total population, because for every 10,000 people of the total population, 61 of them died in the year 2010. So we need to take this number and divide by 10,000. Well, if you do that, you just move the decimal point 4 places to the left. You get 455.6. After that, of course, you'll have to multiply by 61. You'll get 27,791 deaths that year. More children were born in Ireland in 1990 than in 2000. So we want to give a reason why this statement is not necessarily true. Well, it depends on the population. The population in Ireland in the years 1990 and 2000. Okay, here are the figures for 1990 and 2000. Indeed, the birth rate, the number of births per 10,000 of the population in 1990, 151, is greater than the birth rate in 2000. But the total number of births in the year 1990 may be less than the total number of births in the year 2000, simply because the population in the year 1990 may have been considerably lower than the population in the year 2000. So these figures only refer to rates, number of births per 10,000. So we need to know what the population is for the year 1990 and the year 2000 to make the comparison. Next we will get the ratio birth rate to death rate for the 2 years 1990 and 2010. So you just go to the table and look for the birth rate for 1990 and the death rate for the same year, and you divide 151 by 90 to get that ratio. Do the same for the year 2010. You divide 165 by 61. So we can see that the ratio for 2010 is actually greater than the ratio for 1990, even without doing the division. We can see that 165 is greater than 151. So the top part of this fraction, the numerator, is greater. But the denominator, 61, is smaller than the denominator here. So if we increase the numerator from 151 to 165 and decrease the denominator from 90 to 61, we clearly increase the overall ratio. So the ratio of births to deaths has increased. So that's what we want if the population of the country is to increase. We want to increase the birth rate, which is what happened from 1990 to 2010, but at the same time either keep the death rate the same or even decrease it, and it's actually decreased. So that's what needs to happen if the population is to increase. The birth and death rate over the 21 years are plotted against each other in the scatter plot below. The correlation coefficient between the two sets of data is minus 0.85. Now, as a reminder, the correlation coefficient R is a number that lies between -1 and +1. Perfect negative correlation means that all the data lie on a straight line that has negative slope. The actual value of the slope doesn't matter. What matters is that the points lie on a line with negative slope. Perfect straight line, that would be a situation where R is equal to -1. So as X increases, Y actually decreases, and vice versa. As Y increases, X decreases. Okay, so if we go back to our data set, these points do not lie in a perfect straight line, so the correlation is not -1. But it's minus 0.85, which is a pretty strong negative correlation actually. So as the death rate increases, the birth rate decreases, and vice versa. As the birth rate increases, the death rate decreases. So why is it that in general, as the birth rate goes up, the death rate goes down? This rectangle represents the population for a particular year when the birth rate is high. Okay, so in this particular year, the number of young people shoots up because the birth rate is high. But let's suppose that the number of deaths is constant, so we don't have any major catastrophes happening to elderly people. So what's happened to the population for that particular year? Well, it's gone up. Okay, to calculate the death rate, we take the number of deaths that year, which hasn't really changed, only the birth rate has shot up, but number of deaths is more or less constant as it was in, say, the few previous years. We put that over the population, we get this fraction, the fraction of people that died that year. We multiply by 10,000 to get, on average, the number of people that die per 10,000 of the population. But of course, if the population goes up and the number of deaths hasn't changed, well, obviously the death rate is going to go down. Okay, if we blow up the denominator, keeping the number of deaths constant, the death rate goes down. So, yeah, that's what happens when the birth rate goes up. In general, the death rate will go down. We have a disproportionate number of young people in our population when the birth rate is high.